Hello and welcome to the solutions video for our April 22nd assessment battery. This time the skills are arranged from most to least popular. So starting with the two skills completed by 4 students each, then 3 students, 2 and down. So we are starting with trigonometry. Now here we are given the side length lowercase a and the hypotenuse. The randomizer might also give you side length b and the hypotenuse. Either one has identical approach. We want to completely solve the triangle, expressing all angles and lengths to the nearest tenth. All right, so given the hypotenuse on one side, we can use the Pythagorean theorem. That's the way to do it in one step. And also using the information in the original question, which is always my preference. As I say, if you make a mistake in part A and then reuse that in part B, well, part B is wrong now too. But if you go back to the original information in the question, then you shouldn't have an issue. So we can rearrange our Pythagorean theorem here. Our hypotenuse is 42.0 units long. I'm going to write in the square root in the last step. This side is 28.4. So with this, so the square root, we can now go to our calculator. Square root of 42 squared minus 28.4 squared. That works out to 30.9. So this is 30.9 units for length B. Now we can go angle A. One of the reasons I jumped to B first is so that we have the relative proportions. So now we know for sure A is smaller than B. Sorry, knowing A is smaller than B tells us angle A should be smaller than angle B. Well, if we are looking for angle A, we go back to the original information of the problem, then lowercase a is our opposite, c is our hypotenuse. So we take the inverse sign of the ratio, 28.4 over 42. And in degree mode, we get 42.5. For our angle B, again, going back to the original AC in the problem, that means using the cosine. So we're doing the inverse cos of the same 28.4 divided by 42.0. And we get a 47.5 degree angle here. Now in this one, Aaron walks 3 blocks west, then 4.1 blocks south to get to Karin's house. I'm going to turn the annotations on. So we've got 3 blocks west and 4.1 south. Now so that is 3.0. This is a 4.1. So now we need to know, so that's the information that we have. That's actually enough for the diagram for part 1. Now we need to know what direction to go. West of south, if your south goes here, that is west of south, which geometrically is the same as this bottom angle here. So west of south is where you start going south and then move towards the west axis. Right, north is up here, and I'm out of the range of where I can do my sketch. That's east, west, south. So in this case, if we take 3 as the opposite and 4.1 as the adjacent, then we'll do our inverse tan 3 over 4.1. And that gives us an angle. I have to turn off the annotations here. That gives an angle of 36.2 degrees. So this completes measurement 4. Right, moving on to relations and functions 8 about function notation. What is the main advantage of using function notation? Nobody wants to make them harder to understand. You might feel that way while you're learning the notation, but that is never the goal. This is about allowing for clearer communication. So the function notation makes it clear what our independent variable is and what the dependent variables are. It doesn't limit the type of functions that can be expressed in any way. And only used in advanced mathematics, you could argue that that is true, but that's not an advantage. That's more of a description. So let's deal with this function. If we calculate f of 13, well, that's substituting 13. So actually, let's not use red unless it's wrong. So if f of x is x squared minus 7x plus 10, then f of 13 is 13 squared minus 7 times 13 plus 10. That's 169. Now 7 times 13 would be 91 plus 10. So we have here 88. So f of 13 is 88. Now at least one value of f of x for which f of x is 0. Well, that could be, right? That would be one of our factors or one of our roots. If we write this in factored form, okay, let's turn the annotations back on. In factored form, hang on, I'm not sure why this is working that way. Okay. Interesting. There we go. It's just a little slow. Okay, so back to the pen. Okay, I'm not sure why this is not recognizing that I'm lifting the pen up. So we'll come back here and say that x squared minus 7x plus 10, this factors as x minus 2 times x minus 5. If this whole thing is 0, well, if you multiply two numbers together and get 0 as the answer, one of those two has to be 0. So either this bracket is 0, which means x equals 2, or this bracket is 0, which means x equals 5. So either 2 or 5 should be a correct answer for this. Oh, sorry, I had other work up here. To confirm, x, we can graph it, x squared minus 7x plus 10. It does have x-intercepts at 2 and 5. Either or both of these should work as a correct answer. So at least one value, we're just going to put 2. Now here, same thing, if we're substituting negative 9, well, 3 times negative 9 minus another one is the same as 4 times negative 9. This one is negative 36. Now here we're going the other way. Y is negative 21. We need to find x. So we have negative 21 equals 3x minus 9. We add 9 to both sides. Negative 12 equals 3x, and x is negative 4. We can confirm that. Negative 4 times 3 is a negative 12, minus 9 is a negative 21. So negative 24 is our answer here. This completes relations and functions 8. Okay, moving on to our third measurement. So we have a tetrahedron whose edges are 7.2 centimeters long. Well, the volume is a cubed over 6 root 2. So to the nearest tenth of a cubic centimeter, we take 7.2 cubed. In our calculator, divide that by 6 root 2. And that's 43.98769864, or to the nearest tenth, 44.0. The area is a squared times root 3. 7.2 squared times the square root of 3. That works out to 89.8. So now we have the area of a pentagon. We have a right pentagonal prism, which is 7.8 centimeters long. The length of the sides on the pentagonal base is 4.4. So what we have, our base is a prism, and then it comes straight up from there. Pretend these lines are actually straight. So each of these is 4.4 centimeters. And then the height is 7.8. So the volume of this prism, that's the area of the base times the height. The area of the base is 1 over 4 times the square root of 5, open the bracket, 5 plus 2 root 5, close that bracket, and then times our a squared, which is a 4.4. So 4.4 squared. So I'm getting the volume of 33.3 when I multiply all that out. Oh, no, I'm not. I'm getting an area of 33.3. I haven't multiplied by the height yet. Okay, so I'm getting 259.8. Almost made a big mistake there. Now the surface area, the top and bottom are each 33.3. That I figured out last time. The height is a 7.8 times a 4.4. So we have two of these sides, top and bottom, are both 33.3. And these rectangular sides are 7.8 times 4.4. So we're 33.308. I copy and paste that in the calculator and multiply it by 2. And then I add 5 times 4.4 times 7.8. And I get a 238.2 to the nearest tenth. And if you replace the prism with a pyramid of the same base area and height, for the volume you just divide by 3. There's a hint here. If you don't remember the rules for shapes that taper to a point, compare the equation for the volume of a cylinder to the equation for the volume of a cone. So we take our volume of 259.8058513, divide that by 3. And to the nearest tenth, that's 86.6. All right, that wraps up measure 3. Moving on to relations and functions 5, which is mostly about domain and range. Why is it important to understand domain and range? This will help us better analyze the behavior of functions. We know it's going to be contained within these areas. Doesn't necessarily help us simplify. Slope may not even be meaningful for a function with domain and range, or a relation with domain and range. And it doesn't necessarily help us find the intercepts unless the axes are excluded. But that's a special case. This is about analyzing behavior of functions. So if the function has a domain, the square bracket is our interval notation saying 0 is included. And infinity is always the round bracket because it's not a number. It just goes from 0 up. The range. Well, this just gives us the domain. We cannot say anything about the range because we don't know what the rule is. For all we know, our function is y equals 4, but just restricted to this domain. It could be y is the square root of x, which would be restricted to that domain, but have all positive values. Right? That would be b, but y equals 4 would not. So we generally cannot say anything about the range, only knowing the domain. So if the domain of a function is restricted to x greater than 0, what does that imply about the inputs and outputs? Well, it means the inputs cannot be negative. X is our input. Negative numbers are excluded. That's what it means. We know nothing about the outputs. And the inputs cannot be any real number because those include the negatives. So what analogy is best used to explain the concept of domain? Well, the domain are what you feed into your function. That's the input to produce the output. That's just like you put ingredients into a recipe, follow the rules of that recipe, which would be our function, and then the output would be the range. How does the concept of range relate to inputs and outputs? The range is the set of all outputs of the function. It has no bearing on the input value, so B and D are out. And it doesn't describe the restrictions on the inputs either. It's all about the outputs. So B, C, and D can be eliminated quickly. This wraps up our conversation about domain and range. Okay, moving on to relations and functions 6. So if we have a vertical line passing through the point -1, 4, all vertical lines are of the form x equals -1. So in our y equals mx plus b form, it's really just y is 0. This is the usual form. The other way to do it, because we have all of the possible y's, all that matters is the input for a vertical. Right? We can't have the y in there at all, so you might try going that y equals, 0 equals x plus 1. This is true when anytime x is -1, no matter what y is. It is not the preferred form. The top one is the preferred form. The bottom I could accept if you were trying harder to get it into that y equals mx plus b form. But really, x equals -1 is the best way to do it. All right, we have a slope of -3/4, and it passes through the point -1620. So this is y minus 20 is -3/4 times x plus 16. And we are looking for the y-intercept on the graph. So we can let x equal 0 and solve for y. Y minus 20 is -3/4 times 16. Y minus 20 is -12. And y equals 8. Okay, sorry, we don't need mail notifications popping up in the middle here. So that's our y-intercept. So which equation has an x-intercept of 5? When y equals 0, x has to be 5. A seems to fit that pattern. In B, it would be -11. C, y equals 0, x is going to be 3. And D, x would be -5. The y-intercept of 13. You'll notice now these are the same 4 equations rearranged. Just a different order for the same 4. So which equation has a y-intercept of 13? We let x equal 0 solve for y. And again, randomizer, put it as a. Negative 65 divided by negative 5 is 13. Here, x is 0, y would be 5. X is 0, y is 11. X is 0, y is 17. All right, so now the slope point form of the equation shown could be. It's not guaranteeing it, but it could be. Well, let's take a look here. We know we have a positive slope, and all the slopes here are either plus or minus 1. So that tells us it's either got to be A or C. It looks like the slope is more like 4/3 if we count it out. But we have A or C. Does not go through the point 2,3. It does go through the point 3,2. So that is the best fit. It really should have a more precise slope. I apologize for that. I will try not to use this question for that reason in the future. Moving on to algebra and number 4. We want to simplify the following. Well, we're just adding two polynomials. 5x squared plus x squared is going to give us a 6x squared. So it's one of these first three. A positive 4x plus a negative 4x, the linear term is going to cancel. So it's not the 8x, it's either A or B. The negative 1 plus another negative 1, those don't cancel, those combine. So that leaves us with A. Again, here we have to watch because we have our second polynomial out of our conventional order. The linear x comes before the x squared. 3 minus 1 is a 2x squared. It puts us as one of these two. That 11 is a trap to catch the students who don't notice that the second one is not in the same order. Now, 4 plus 8 is 12, which we knew. Once we have it narrowed down to B or C, they both have 12x. And then our constants combine to make a negative 10 because they're both negative 5. Here, multiply this and simplify completely. Well, 7r times r is 7r squared. Now 7r minus 1s, when we are multiplying those, that's a negative 7rs. 8s plus r times r is a positive 8rs. And then we subtract 8s squared. So 7r squared plus rs minus 8s squared would be our final answer. So that is our final simplification here. Now here, a negative 2x squared minus x squared, that's a negative 3x squared. Not super surprising because that narrows down, or that's 3 of our 4 responses. The fact that 2 of them have a 3x shared, not surprisingly, that's what this becomes. So we've got it narrowed down to these. A negative 2 minus negative 6 is a negative 2 plus 6. That's a plus 4. That negative 8 really should be an option up here. All right, now we expand and simplify here. We could see they all start with 56h cubed, all end with plus 3. So our cubed and our constants are not going to make a difference. Now there's 2 of our 11 h's with different signs. Our b terms do not agree. Our c terms do not agree. So we can really pick either one of those and run with it. I'm going to do the rest of this with the box method. So we have a quadratic times a binomial. So we have a 7h squared minus 4h plus 1. And then 8h and 3. So we multiply these together, we get our 56h cubed. What we really want to check are our two diagonals, how these combine. So 7h squared times a 3 is a 21h squared. 8 times a negative 4 is a negative 32h squared. So we combine these to make a negative 11. That only exists here. For extra practice, or if we want to be ready in case this is written response or something like that, the negative 4 times 3 is a negative 12. We combine these. That does give the negative 4h we had here, and then 1 times 3 is 3. If the 1 times 3 is 3 part is an issue, maybe you should check which course you're enrolled in. Next up, algebra number 5, where you're going to look at factoring. So what factors of 5, or what factors of 5 add up to 6? Well, that's just 5 and 1. So this has to be x plus 1y times x plus 5y. Now, next up, so 9x squared is a perfect square, 4y squared is a perfect square. This is a candidate for the product of perfect squares. If we had the product of perfect squares, we would have a 3x plus 2y squared. When we multiply them, we would have 2 terms of 6xy. Those are what we call our cross terms. Middle term of 12xy. That's exactly what we've got. So this is indeed 3x plus 2y all squared. Okay, so next, so 16 is a perfect square, 1 is a perfect square. We check it again. If we have 4 times 1, that's 4. 2 of those, we get 8. So here is another product of perfect squares. Now this can't be. 2 is not a perfect square. 55 is not a perfect square. So we need factors of 2 and factors of 55 that we can multiply together to make, and then add to make 21. We know we're adding because 21, or 55 has a positive sign, tells us the sign in our two terms match, and they're going to be whatever our middle term is. We know we're adding. So if we multiply either 2 or 1, right, it's the only two factors is 1 and 2. 55 could either be 1 and 55, in which case we're not going to get 21 because it's 55 or 110 plus something, or 5 and 11. If we have 2 times 11, that makes 22. Add 5, we get 27. So we have to have 2x times 5y, which means our 5y would be in the other bracket. That would be the x. We'd have 11y here. So 11 plus 10 is 21. We have 2x plus 11y. And that's x plus 5y. Okay. So next up, our cross term is exactly one more than our constant. Our first term has a coefficient of 0. That's the same as our x squared plus 6xy plus 5y squared. It's a pattern, not one that's usually dealt with explicitly in our program of studies. Sorry, wrong key. But it means it's going to be y and then 8y. So the cross term becomes 9. That wraps up algebra number 5 on factoring. All right, continuing on to relations and functions 7. A linear relation passes through the point 919 with a slope of 4. So the slope point for me is the easiest one to do. So that's y minus the coordinate of our y, which is 19. There's a slope, and x minus the x-coordinate of our point. So that's it. That is our slope point form. For slope-intercept form, you have to multiply the 4 through the brackets. So our first step, I'm just going to use regular typing instead of the equation editor, just to make it a little bit faster to type. Now we add 19 to both sides. Cancels on the left, and they combine on the right to make a negative 17. So I'll do this with the equation editor so it stands out. That is the final answer. Y equals 4x minus 17. General form, this means that we're going to have the coefficient of x has to be positive. We're not going to have any denominators, which we don't. So this works out to 4x minus y. We either then say minus 17 equals 0. That's the general form of the quadratic. I will also accept the 4x minus y equals 17 and just call it done. Both acceptable responses. All right, now we're into the topics that were done by one student each. So algebra and number 1. Which of the following is not a method to find the least common multiple? It's averages. Averages mean nothing for it. You can multiply your two numbers together, divide by the greatest common factor. That'll give you the least common multiple. You can do prime factorizations of both numbers and take the highest exponent of each base you see. That will produce your least common multiple, or you can just list all the multiples. So the other three definitely work. So the greatest common factor is important in mathematics because it allows for simplifying fractions and solving problems involving equal sharing. So simplifying fractions, you remove the greatest common factor from numerator and denominator. You can also do equal sharing. Now, this is a question, it's a little vulnerable to guessing. Just a little bit of test taking. If you are clueless about something and one option is much longer than the rest and not obviously a joke, it's probably the longest one. So which of the following numbers is neither a perfect square nor a perfect cube? Well, 16 is 4 squared. 125 is 5 cubed. 729. That is actually both. It's 3 to the 6. So this is both 27 cubed and 81 squared. 26 is 2 times 13. So that is neither a square nor a cube. So prime numbers have exactly 2 factors. One has only one factor. 0, you could argue, actually has unlimited factors. Right? You take 0 divided by anything and you'll have 0 remainder. Right? 0 minus 5, or 0 divided by 5 is 0. 0 divided by 87 is 0. It's actually infinitely many factors. So neither is prime because neither has exactly 2 factors. Okay. So now, algebra and number 2, dealing with rationals. If you were to place the square root of 22 on a number line, where would it approximately fall? Well, that's between the square root of 16 and the square root of 25. Now, Newton's method for finding approximate square roots. So there's a worked example here. If you want to find the square root of a, you take your guess and you average your guess and the number divided by your guess. That's what the divide by 2 is. So if you have 19 over 6, well, multiply 10 by that reciprocal, you get 60 over 19. If you have 721 over 228, multiply 10 by the reciprocal, you get 2280 over 721. You keep averaging these, and then we get a number that's accurate to the thousandth place. So we want to approximate root 23 to the nearest thousandth. Now, one thing we can do here, we start by using our calculator to find the square root of 23. So our target is 4.796. That is accurate to the nearest thousandth. It's 7 or 4.795831523 reading off the calculator. What we want to do now is find the fraction that gets closest to that. So 23, the closest square root is probably going to be 25. That's our closest perfect square. So I'm going to say the first guess is 5. Our second guess would be 5 plus 23 over 5 all over 2. Our numerator over common denominator of 5 becomes 25 plus 23 over 5 all over 2. And that should be a 23. It's not super clear. That's 48 over 10, which reduces to 24 over 5. This will be 4.8 as a decimal approximation. Not accurate enough yet. X3, we're going to have 24 over 5 plus. Now 23 times 5 is 115. That's over 24, and the whole thing is over 2. So if we take our numerator, you're going to have 576, that's 24 squared. 5 times 115. So 576 and 575 all over 5 times 24, which is 120, and that's all over 2. So this is over 240, and our numerators 575 plus 576, that is 1151. With no useful simplifications, but if we check this as a decimal, 4.7958 and 3 repeating, that is 4.796. That's our target. We're already there. So we hand in the rough work, and what we're looking for is 1151 over 240. But we don't need the letter C there. So 1151 over 240 is an approximation to 3 decimal places. So, which of the following best illustrates the differences between rational and irrational numbers? Rational numbers are whole numbers. Not always. Rational numbers are always positive. Nope. Rational numbers can be expressed as decimals. True. Irrational numbers cannot. No, they can. They're just not terminating or repeating decimals. Rational numbers can be expressed as fractions. Irrational numbers cannot. That is the actual definition. That's the one we want. Now this one, which is an example of a rational number? Well, negative 3 over 4 is definitely rational. Root 5 is not a perfect square. Pi is the most common example probably of an irrational number. And 127 is not a perfect cube. It'll be a little over 5 because 125 is a perfect cube. So this wraps up algebra and number 2. Moving on to algebra and number 3. Okay, so now x to the 5 over 4 squared. Well, we multiply exponents of exponents, so that's x to the 10 over 4, which reduces to 5 over 2. So that's the square root of x to the 5. Now, when 27 over 8 to the negative 4/3 is evaluated and written in the form a over b. The value of b is, that's our denominator. This is a few steps, so I'm going to write this one out. So 8 over 27 to the negative 4 over 3. If we deal with the negative first, that's just taking the reciprocal. Now, when possible, always take the roots before doing the expansion. You'll get much smaller numbers that are easier to work with. So the cube root of this makes it 3 over 4. We bring that to the 4. 3 to the 4 is 81. 2 to the 4 is 16. So our denominator is 16. This is one you could type into your calculator exactly as is, tell it to write your answer as a fraction, and that'll give you the 16. Now here, the expression 40 and 2 over 3 can be written as a mixed radical of the form a and then bc. Our index is not going to change, so the b is going to be 3. The number itself, so if we have 40 to the 2/3, this is the cube root of 40 squared. But 40 is 2 cubed times 5. So this is the cube root of 2 to the 6th, 5 squared. 6 is a multiple of 3. Or it's greater than or equal to 3. We could pull that one out right away. Divide 6 by 3. We get 2 squared. But here our exponent 2 is less than 3. That has to stay inside. So our final simplification, this is 4 cube root 25. Or 4325. The cube of the square root of m. So the square root puts a 2 in the denominator, the cubit puts a 3 in the numerator. This negative would reciprocate it, that's not what we want. And this is the cube root of m with no 2 involved anywhere. So a value equal to 81 over 625 to the 1/4. That's the 4th root, which actually is 3 over 5. We can't use the negative to reciprocate the exponent. We could say 625 over 81 to the negative 1 over 4. We can't do this. Now, for part C, they have reciprocated, even though there's no negative exponent, and then divided everything by 4. So here they did the reciprocal and added the negative, but they also reciprocated the exponent. If this exponent had been 1 over 4, it would have worked too. This wraps up algebra and number 3. So moving on to measurement 2 with unit conversions. The speed of light is 299,792,458 meters per second, and there are an average of 365.24 days in a year. Yeah, it's not quite 0.25. If the turn of the century is a multiple of 100, there's no leap year unless it's also a multiple of 400. So 1900, 2100, those are not leap years. If 1 light year is the distance traveled in 1 year, what is the distance of 3.28 light years expressed in kilometers? I'm seeing a common error in here when we're converting units is to do it in meters, not kilometers. So if you're off by a factor of 3 in your final exponent, if your final exponent of 10 is 3 too high in scientific notation, that'll be what did it. All right. So we need to figure out what distance light travels in 3.28 years. So we have 299,792,458 meters per second. Now, how many seconds are in a day? There's 60 seconds in 1 minute. 60 minutes in 1 hour. 24 hours in 1 day. And 365.24 days in 1 year. So 299,792,458 times 60 times 60 times 24 times 365.24. I'm sorry, the decimal's not very clear. And this is 9.46 times 10 to the 15 meters. We need kilometers. So 5.46 times 10 to the 12 kilometers. Or in our numeric response, that is 94612. If you put the 15 there, or if you had a 16 instead of a 13, depending on how your randomizer went, then you missed converting meters to kilometers. All right, so we have some conversions here. We need to convert kilometers to meters. That's just multiplying by 1,000. Every kilometer is 1,000 meters. Now 15.2 Celsius to Fahrenheit, that's 9 over 5 times 15.2. And we add 32. Our calculator says 59.36. To the nearest tenth is 59.4. Now, how many pounds to a kilogram? 1 pound, or 1 kilogram is 2.205 pounds. So the pound is the higher number. We need to make it smaller, so we divide 59 or 50.9 by 2.205. That gives us a 23.1 kilo. Now, millimeters to inches, that's standard up here. If 1 inch is 2.54 centimeters, then 1 inch is 25.4 millimeters. 23.9 times 25.4 to the nearest tenth is 607.1. All right, and just doubling back a bit, I always check against the answer key before moving on. And I realized in this problem, when we were converting light years into meters, I got the conversion between meters and kilometers. What I forgot to do after that was actually multiply by the 3.28 for the number of light years that we had. So we do this times our 3.28 light years. And then our number here is 3.103 yada yada times 10 to the 13. Okay, so I apologize for missing that piece. Okay, moving on to relations and functions 1. So identify the discrete variables in this list. So these are ones that cannot take on any value. It's only specific values. You can't have a shoe size of pi. Elapsed time you could measure as accurately as you like. Number of library books you can count. Speed of an asteroid you could take any decimal place. Same with temperature of a room and mass of a stone. So shoe size and library books are the only discrete values here. Next, one disadvantage of bar graphs. Well, yeah, it is difficult to show changes over time. We do all graphs because it makes it easier to compare the data. The category that's least popular in this graph, we can see it's marmalade. It's the one that's usually the shortest bar. Difficult to count the data, not in the well-designed graph. Here these items are 2 apart. We know if it's in the middle, it's 17 because this is discrete data as well. So in this graph, how many people like peanut butter on their toast? It's between 16 and 18. That is 17 because you're probably not going to have 16.8 people. That would have a lot of paperwork. All right, so now if the company's total expenses were 76,430. How much is going into labor? Labor's 31%. 76,430 times 0.31 is $23,693.30, but it asks us for the nearest dollar, so we can scrap the 30 cents. How much more money was spent on machinery than on workplace materials? Well, that's a 10% difference. Machinery is 27%, workplace materials is 17%. So 10% of our original is 7643. Okay, this should wrap up relations and functions 1. Okay. Moving on to relations and functions 2. What's true about functions? Always a straight line. Nope. At least one output for every input. No, we don't want to say at least one because that allows 2 or 3 or 4, and that's not allowed. Function can have the same input with different outputs. No. Multiple inputs for the same output. That's allowed. Each input can have one output, but every input can have the same output. Y equals 3 is a function. It passes the vertical line test, and every possible input gives you the same output. So if a vending machine gives you either chips or a candy bar when you press button A1, what does that indicate? Well, it is not a function, right? Because 2 inputs, or 1 input gives 2 outputs. You push A1, you might get chips, you might get candy. So it cannot be a function because it has multiple outputs for 1 input. Example of a non-function. This one where the input 1 has outputs 2 and 3. Everything else, our input, our first number, is different every time. So what defines a function in relation to its inputs and outputs? Each input has exactly 1 output. That's what defines a function. It's true that an output can have multiple inputs. Like we said, y equals 3 works. That doesn't define a function. Okay, exactly 2 inputs is certainly not the case. And each input can have multiple outputs. Also not the case. What is a relation? It's a connection between 2 sets of items. It tells you if you take an item from one set as your input, then an item from the other set is an output. You can have graphs with points. A function is a type of relation, not the other way around. And they're not necessarily just sets of ordered pairs. You could connect first names and last names. It's just a relationship between 2 sets. All right. A line with a slope of -2 goes to the points -1k and 2, 2. The value of k is. So this means we have y. If we put it in slope point form using the known point 2, 2, y minus 2 is a -2x minus 2. And when x is -1, what value does y have? Well, let's substitute. X is -1 minus 2. So that's a 6. When we solve, y is going to be 8. Now, given this equation, what's the slope of the line? For that, we are going to have to simplify. So we have 21y uh, 19x plus 9 plus 8x plus 12. So 21y is a 27x plus 21. Y is a 27 over 21x plus 21. Now 27 and 21 are both multiples of 3. So that simplifies. This is also over 21. So we end up with a plus 1. All right, we have our equation. The slope of the line is 9 over 7. It specifically asks for reduced fraction. But again, Math 10, you don't have permission to use decimals unless it says so in the question. All right, we have 2 points on a line with a given slope. What is the coordinate of one of the points? So our points are -3, -20, and 9h. Slope is the change in y over change in x. So I'm putting 9h first. -3, -20 is second. And this is equal to 11 over 4. So h plus 20, 9 plus 3 is 12, is 11 over 4. We multiply both sides by 12. It cancels on the left. 12 over 4 becomes 3, so we get a 33 when we simplify on the right. So h is 13. Now, we have 2 points. They are the same line. What's the slope? Our y doesn't change. Change in y over change in x is 0 over something. So our answer is 0. Okay, now this is a very similar problem to this one. So we can use the same steps with different numbers. But we're going to have 19 over 20. And our denominator is going to be a -20 when we take a -3 divided or minus 17. So the right is -19. Now we add 17. No, the 17 was in the denominator. We are adding 8 to that. So here h should be -11. If we have -11 minus 8, that's a minus 19. -3 minus 17 is a -20. So this works. That wraps up relations and functions 3. Okay, moving on to relations and functions 4. The y-intercept of this function, we could read off it directly in slope-intercept form. Y-intercept is a -14. The x-intercept. To find the x-intercept, we let y equals 0. When we solve for x, that's a 14 over -2. That gives us a -7. And now, here we go. Our last of the written response, I believe. Nope, second last. I was wrong. We do have another one coming. So 5x minus 8y minus 19. We want to find the x and y intercepts. Okay. So if we have 5x minus 8y minus 19 equals 0. To find the x-intercept, we let y equal 0. That's a 5x minus 19 is 0. 5x is 19. X is a 19 over 5. So that's our x-intercept. And our y-intercept is when we let x equal 0. So that's a -8y equals a positive 19. So y is a -19 over 8. That's our y-intercept. Okay, so this wraps up relations and functions 4. All right, an hour into it. We are in the home stretch. We just have one set of problems left to go. Now here is our last equation. We are solving this by elimination. But our first equation is not in a useful form. We have to convert it first. So we have 2x minus 1 over 3 minus y plus 5 over 5 and that equals 4. If we multiply everything by 15, then that will wipe out both denominators. We'll have to multiply the first numerator by 5, gives us 10x minus 5. Our second by 3, and we have that negative here, so a minus 3y minus 15, that equals 4. So now we have 10x minus 3y. We have a negative 20 on the left. When you move it to the right, we have a positive 24. Now we have a negative 4x plus 5y is 6. So now, specifically when we're doing elimination, we need to find the least common multiple of one of these. I'm going to go with eliminating x. We could multiply the top by 5 and the bottom by 3. I'm going to multiply the top by 2 and the bottom by 5. So if we do that, our new system, multiplying the top by 2 is 20x minus 6y is 48. Multiply the bottom by 5. It's a negative 20x by design. It's this with a different sign. Plus 25y is 30. Now when we add these two together, we have eliminated our x. That was the point. We have a 19y here and a 78 there. So y is 78 over 19. This doesn't simplify because 78 is not a multiple of 19. Once we have that, we could plug it into either. I'm actually going to do my elimination the other way now. So now I am going to go back to this one, multiply the top by 5 and the bottom by 3. That gives me 50x minus 15y equals 120. Multiply the bottom by 3. It's a negative 12x plus 15y equals 18. Add these two equations. We get a 38x. The y's are eliminated by design. And that equals 138. So x is 138 over 38. These are both even. So we have a 69 over a 19. That does not simplify either. Okay, so now we can check these. This will be easier if you check it in your calculator by storing the numbers. Let me actually do an on-screen calculator for the storage to really show how that works. So we will launch this through TestNav. I'm going to start. Again, start session 1. With our TI-84 graphing. Okay. So y is 78 over 19. I'm going to say 78 over 19 gets stored in y. And 69 over 19 gets stored in x. So now that I have that, I can write negative 4x plus 5y. Negative 4x plus 5y. That's the 6 we're looking for. Now 2x minus 1 over 3. Minus y plus 5 over 5. That equals a 2.6 repeating. That is not a 4. Did I do something incorrectly up here? Okay, well, Desmos is good for double checking things quickly. So negative 4x plus 5y equals 6 is this line. And then 2x minus 1. 2x minus 1 over 3 minus y plus 5 over 5. And this is supposed to equal 4. And they meet. Okay, 11 and 10. So I do have a mistake somewhere. Okay. So double check that. 11 would make that 22 minus 1. Yes. So 21 over 3 is 7. 15 over 5 is 3. 7 minus 3 is 4. So that one checks out. Our negative 4x, negative 44, right, plus 50 is 6. Yes, that checks out. So here if we have 11. Okay, it was something I did in this step here. Because at 10x, oh, there it is right there. This shouldn't be 4 anymore. That was the issue. Because I had to multiply both sides by 15, forgot to multiply the 4 by 15. That's a 60. So now a 60 plus 20, that's an 80. Okay, that will change things pretty dramatically. Apologize for that. But this is why it's always good to check your answers on your test. Okay, so again, eliminating x, multiplying the top by 2 and the bottom by 5. 20x minus 6y is 160. Negative 20x plus 25y is 30. Add these up. We still have our 19y here. Nothing on the left would have changed. But now when we add these, we get 190. Y is 10. Okay. Now on the right, when we work these, here we multiplied the first by 5. And then the second, we're going to multiply by 3. Well, 80 times 5 is 400. Now when we add 38x equals 418. And yeah, 418 divided by 38 is 11. We've already gone through and checked that. Okay. So our mistake was found and corrected before turning it in. This is important. So next we have this system of equations. So we can handle this in a few different ways. So one of them, we have permission to use decimals. That also means we have permission to use our calculators, especially since it's numeric response. So if you go back to what we learned in that last lesson on this topic, our first one, oh, sorry, we want 3. Oh, we want a 2 by 3, not a 3 by 2. Okay. So 4, 1, and a 2.5. Now our next is 2, 2, negative 10. Oh. Okay, we can type faster than this can keep up, apparently. Oh, right, and I was using the keyboard, I hit minus when I wanted negative. All right, so now we have it all entered in our matrix. I'm going to take the math with our matrix. We want the reduced row echelon form, or RREF, for matrix A. And that gives us, our first variable is 2.5 and our second is negative 7.5. We were asked for 1 decimal. So 2.5 and negative 7.5 are perfectly acceptable. Now, we want to attempt to solve the following system of linear equations, which is the number of solutions. Well, if we look at these are, the first one, we have the same proportions. The coefficient of A is 1.5 times the coefficient of B. You can actually get from 6A plus 4B to 9A plus 6B multiplying by 3 over 2. But if you were to multiply 15 by 3 over 2, you wouldn't still get 15. So these lines are parallel but distinct. So there are 0 solutions. They are parallel lines. All right, so with that, we can submit. And when this eventually comes up, there we go. 85 out of 85, that's the score we're looking for. Of course, individuals in class, you're out of at most 15.